In this video, we are going to see how we could solve rational expressions. So, a rational equation, an equation first is some function, let's say 4x minus 5 equals 0. We have a function here, and we could have 4x equals 5, and x is equal to 5 over 4. But an equation with rational expressions contains a rational function. So, for instance, we have 4 minus x divided by 5 minus x squared equals 0. That is a rational function. Why? We have a numerator and we have a denominator and we have a fractional function which we call a rational function. So here is an example. The first thing to do is to find a common denominator and combine multiple terms into a single term. So we have 5 over 3x plus 1 on the left-hand side. I could write that 1 as 1 over 1. If I want to combine those two, we need to find the LCD. There is nothing in common between 3x and 1, therefore the LCD is 3x. So the first term is simply 5 over 3x. I'm going to multiply and divide the second term by 3x. So 1 times 3x over 3x. So I would have 5 over 3x plus 3x over 3x. Have a common denominator, 3x. So I simply combine the numerators. So I had multiple terms here on the left-hand side. I combine them. I'm going to write it as 3x equals 7 over 6. So we have one single term here equal to one single term there. If we arrive at this point, all we have to do is something called cross multiply. In other words, we're going to multiply 6 with 5 plus 3x and 7 with 3x. We distribute on the left-hand side. We have 30 plus 18x equals 21x. Move all the x's to one side, which would mean 30 would equal 21x minus 18x. 21x minus 18x is 3x. This would imply 3x is equal to 30. X would be 30 over 3, which would mean the solution is x is equal to 10. So here we have another rational equation. So this side we have a single term, there we have two terms. So our first objective is to combine the two terms on the left-hand side to get a single term. So we have 1 over 2x minus 1 over x plus 1. We have to find a common denominator in order to combine the two fractions here. So there is nothing in common between 2x and x plus 1. So the LCD is 2x times x plus 1. Our objective now is to convert the denominator in the first function here to 2x times x plus 1. The second function there, the denominator has to become 2x times x plus 1. So I am going to multiply and divide the first fraction by x plus 1 and the second fraction by 2x. So I would have x plus 1 divided by 2x times x plus 1 minus 2x divided by 2x times x plus 1. We have a common denominator, so we combine the numerators, x plus 1 minus 2x, which would give us 1. X minus 2x is minus x over 2x times x plus 1. So I have successfully combined the two terms on the left-hand side. To get that. On the right-hand side, I have 3x squared plus 3x. Now, we might be in a hurry to simply cross-multiply like we did in the previous problem, but at times it is better to take things slow and see if you can simplify the terms. So what do I mean by that? On the right-hand side, I have 3x in common, which would give me 3x times x plus 1. If 3x comes out of 3x squared, I'd have x, and 3x comes out of 3x, I have 1. So in the denominator, I see that term and that term in common, so those two would get cancelled. That's algebra. So those two would go away, and we would end up having 1 minus x over 2x equals 1 over 3x. And lucky for us, we have x in common also. So that term and that term would go away. We have 1 minus x over 2 equals 1 over 3. We have simplified it really nicely, so now I could cross multiply to get 3 times 1 minus x equals 2 times 1, which would imply 3 minus 3x equals 2. Move all the x's to one side and numbers to the other. 3 minus 2 would equal 3x. 1 would equal 3x. This would imply x is 1 over 3. Here is a function which is simple to begin with. So what we have to do is simply cross multiply. A single term on the left-hand side, single term on the right-hand side. No simplification necessary at the beginning. No rearranging terms. No combining terms. We can simply cross-multiply directly. And if we cross-multiply, we end up getting 1 times x plus 1 equals 2 times x minus 1. That would give us x plus 1 equals 2x minus 2. Move all the x's to one side and numbers to the other. So 1 plus 2 would equal 2x plus x. 3 would equal 3x. That would imply 3x is equal to 3. X is equal to 3 divided by 3. So the solution is 1. Here we have an interesting situation where we have a single term on the right-hand side, so nothing to worry about there. But on the left-hand side, we have these two terms. So our first objective should be to combine those two terms. So 12 over 9 minus a squared plus 3 over 3 plus a. We have to find a common denominator. So if we recall the identity, a squared minus b squared, perhaps I should use different letters here. X squared minus y squared is x plus y times x minus y. So in the first denominator, I see 9 minus a squared. I could rewrite it as 3 squared minus a squared, because 3 squared is 9. So x becomes 3 and y becomes a. So I would have 3 plus a times 3 minus a. So the first denominator, 9 minus a squared, I could write it as 3 plus a times 3 minus a. The second denominator is simply 3 plus a. The first denominator, second denominator. Let's find the LCD. 3 plus a isn't common, so I write 3 plus a, and 3 minus a is isolated, left on its own devices, so I write it as 3 minus a. So the least common denominator is 3 plus a times 3 minus a. So let us rewrite the left-hand side. I could rewrite the left-hand side as 12 divided by 3 plus a times 3 minus a plus 3 divided by 3 plus a times 3 minus a. And that would equal, going one step ahead here, and that would equal to 2 over 3 minus a. I want to make this denominator and that denominator to look alike. So I'm going to multiply and divide. The second fraction by 3 minus a. So now we have a common denominator, 3 plus a times 3 minus a, so we combine the numerators, which would be 12 plus 3 times 3 minus a, which would give us 12 plus 9 minus 3a divided by 3 plus a times 3 minus a equals 2 over 3 minus a. Don't be in a hurry to cross multiply. Let's see if we can simplify. We have 3 minus a in common, so we can cancel it out, which would give us 21 minus 3a over 3 plus a equals 2 divided by 1. Now we can cross multiply, because I have a single term on the left-hand side, single term on the right-hand side. So 21 minus 3a times 1 equals 2 times 3 plus a. 21 minus 3a would be equal to 6 plus 2a. Move the numbers to one side and, excuse me, the a terms to the other. 21 minus 6 would equal 2a plus 3a, which would imply 15 equals 5a, therefore a is 3. Here we have a complicated, or a problem that looks very complicated. So we have a quadratic polynomial there, and we have two terms on the left-hand side, the right-hand side. So let's start with the denominator on the left-hand side, x squared plus 7x plus 10. The question to ask here is, could we factor this? We absolutely can. We could write it as x plus 5 times x plus 2. Let's move on to the right-hand side. The right-hand side has 1 over 3x plus 6 and minus 1 over x plus 5. We want to find the common denominator, and there is nothing in common between 3x plus 5 and x plus 5, so the LCD is 3x plus 6 times x plus 5. To get that common denominator in the first fraction, we multiply and divide by x plus 5. to get the common denominator in the second fraction, we multiply and divide by 3x plus 6. So now we have a common denominator because 1 times x plus 5 is x plus 5 in the numerator, and denominator becomes 3x plus 6 times x plus 5. The second term is 3x plus 6 divided by 3x plus 6 times x plus 5. That would imply we have a common denominator on the right-hand side, left-hand side. Oh, it is the right-hand side, I'm sorry. So the common denominator is 3x plus 6 times x plus 5. So combine the numerators, that term. We have x plus 5 minus 3x plus 6, which would give us x plus 5 minus 3x minus 6 divided by 3x plus 6 times x plus 5. X minus 3x is minus 2x, and 5 minus 6 is minus 1, divided by 3x plus 6 times x plus 5. Could we simplify this further? I don't think so. So we just have to stop right there, and we move on to the other side. We have x plus 2 divided by x plus 5 times x plus 2. That is what we did here. We rewrote x squared plus 7x plus 10 as x plus 5 times x plus 2. On the right-hand side, we have 2x minus 1 divided by 3x plus 6 times x plus 5. So those two terms are in common. We cancel them out. We have that term in common. We cancel those two out, and we will simply have 1 over 1 equals negative 2x minus 1 divided by 3x plus 6. So we have a single term on the left-hand side, a single term on the right-hand side. So we cross-multiply to get 1 times 3x plus 6 equals 1 times minus 2x minus 1, which would give us 3x plus 6 equals minus 2x minus 1. Add or bring all the numbers to one side and x's to the other. 3x plus 2x would equal minus 1 minus 6. 5x would equal minus 7, which would imply x is equal to negative 7 over 5.